Hey guys, welcome back. This is me, Sahil Mahajan, and in today's video, we will be discussing about Caesar cipher. So, Caesar cipher is actually one of the earliest known ciphers out there that we know about. It's quite simple, and it uses a substitution technique, which was created by Julius Caesar. This actually cipher basically involves replacing each letter of the alphabet with the letter standing K places further down the alphabet. So just to basically explain you, in this we'll basically be having a key. So in this scenario, we'll be taking our key as 3. Okay, so our K is equal to 3, which is key is equal to 3. So I've written down all the alphabets over here from A, B, C all the way to Z. And now what basically happens in Caesar cipher is we're going to substitute each alphabet. So we're taking K is equal to 3, which means that A would be replaced by 3 characters down the line. So A is there. So 3 means 1, 2, 3. So A is replaced by D. B would be replaced by E because C is 1, D is 2, E is 3. And accordingly, this process will keep going on till we reach the end. Now, for example, let's take we have a plain text over here. Our plain text is, again, I'll write all of our plain texts in white color. So our plain text we want to encrypt is hello world. So in this scenario, how would we encrypt hello world? So basically, we would look at this table we have created over here. So look at H. So we can see H corresponds with K. And because our key is 3 over here, and why do we know it's equal to K? Because I is 1, J is 2, and K is 3. So in that scenario, H is equal to K. So we will replace H with K. Then E would be replaced with H. L would be replaced with O, again L, so O, and now finally O would be replaced with R. And the same going to look at world. So basically W would be replaced with Z, O would be replaced with R would be replaced with U, L would be replaced with O, and D would be replaced with G. So this is the hello world as a plain text, and after encrypting it using Caesar cipher, where our key is 3, this is the encrypted text or cipher text that we are getting. Now, again, this key can be anything that you wish to take. In the scenario, for example, if we take k is equal to 4, then this DEF would completely change. In the scenario, what would happen is each character would move to the left because now if you want to find what is the equivalent cipher of A, we know that k is equal to 4. So B is 1, C is 2, D is 3, and E is 4. So now A would be equal to E. Now B would be equal to F. And basically this D would come again back at the end because each character moves there. So again, K could be anything that you want to take. Now, in the scenario that, of course, you cannot keep, writing this table down and everything like that. So we have a formula that we follow. So, and also, you can also decrypt back. We look at the formula for decryption and encryption, both of them. So encryption. Now let's take, we have our plain text. We want to encrypt our plain text. What is the formula? The formula that we follow is P plus K mod 26. Got it? P plus K mod 26, wherein K is our key that we're taking 3 in this scenario. I'll just omit this from here. K is equal to 3. And now we are taking P is basically going to be the numeric value of the plain text alphabet that we are having. Okay. And then we're going to do mod 26. Now I'll also give you the what we say formula to decrypt. So decryption, the formula basically is C minus K mod 26. Now, what is C? C is basically the cipher text over here. Cipher text minus the key mod 26. So these are the two formulas that we follow. Now, in the scenario that we have over here, A, B, C, D, E, F, G, all the way to Z, what we're basically going to do is we're going to assign a numeric value to each of these alphabets. Now, we will not start with 1. That is, A will not be to 1. We will instead start with the index of 0. So A would be 0, B would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So as you can see, we have 26 characters over here, but we're starting with the zero index. And now, so now basically what we're going to do is now let's take the same example of hello world. We want to encrypt hello world. I'll only explain hello for now. Um, so basically in this scenario, what would happen is we know our formula is P plus K mod 26. Now H, what is the numeric value of H? As we can see, the numeric value of H is 7. So in this scenario, what would happen is 7 plus 3. The reason why we have taken 3 is because our key is equal to 3 mod 26. 7 plus 3 is equal to 10. So we get 10 mod 26. Now, what is 10 mod 26? 10 mod 26 is basically 10. So C is equal to 10. The cipher text is equal to 10. Now, if you guys do not know how to calculate 10 mod 26, I do have a previous video where we do this modulus arithmetic operations. You guys can check that out. I'll link it up in the description and also in the I on the top right hand corner. Again, you can also use a calculator to figure out what is 10 mod 26. So 10 mod 26 is basically 10. C is equal to 10. Now we're coming back to our table over here. What is which character is on the 10th place? We can see that K over here is on the 10th place. So in this scenario, H is equal to K. And we can also verify this with the below table and we can see HK, HK. Now let's take E. Now we know that E is equal to 4. So we're going to do 4 plus 3 mod 26. Now what is 4 plus 3? 4 plus 3 basically comes out to 7. 7 mod 26, which results back to 7. Now let's see which character is in the seventh place on this table. We can see H is the seventh place. So H is over here. And as we can validate that when we were manually doing it, we got K and H, and also using the formula, we got K and H. Now, let's talk a bit related to what we say, how can we decrypt? So in the scenario, we have C minus K mod 26. Now, what we know, we have over here, C is K and we have H. So in this scenario, we're going to go back up. We're going to find what is the value. Just a second, if I can go back up. Yeah, we're going to look at what is the value of K over here. So we can see the value of K is 10. So I'm just going to write this again. I'll just write this in red color. So we're going to take 10 minus 3. The reason why we take it 3 again is because our key is equal to 3. 3 mod 26, which is equal to 7 mod 26, which again results back to 7. Now we know it is 7, so we're going to look at this table again. We know at the seventh place, H is the character, so this K is basically equal to H. Now we're going to take in our next value, that is H over here. Now we know H is at the seventh place, so we're going to take 7 minus 3 mod 26, which is equal to 4, 4 mod 26, which is equal to 4. Now we're going to look at the character at the fourth place. At the fourth place, the character is E, as we can see in this table, which basically means H is equal to E. Sorry, E. Yeah. So as you guys can see over here, we were able to encrypt and we were also able to decrypt. So again, yeah, guys, this is basically Caesar cipher. This is one of the easiest ciphers and simplest substitution ciphers we have out here. Um, Normally, this is the first cipher that people do learn while getting into cryptography. So I hope you guys did understand about Caesar cipher. and about the different way how you can encrypt and decrypt both through manual and also through the formula. So hope you guys did like this video. If you did, please make sure to leave a like. Do comment if you have any doubts and do subscribe. See ya. Take care. Bye bye.